All right, folks, for note 77, I'm going to break this up into one video per problem. There's 3 word problems on here, and each one of them we're going to basically do the same thing. So the first thing I'm going to do is, of course, I'm going to read the word problem. All right. So we got the price of tickets to a show is $16. All right, there we go. There's the highlighter. And 4,000 tickets will be sold. All right. For each $1 increase in price, the number of tickets sold will decrease by 100. All right. So the first thing we're going to need to do, I'm not even worried about the questions yet. We need to make ourselves a function, an equation here, to talk about what's happening with this revenue, right? With the money coming in. So off to the side here, I'm going to kind of blow this up, and I'm going to be moving back and forth here. We can call it f of x, r of x, whatever function you want to call it. I'll go r of x for revenue. All right. And what I want to do is for revenue here, we're going to talk about the money, and we're going to multiply that. I did not give myself enough space by the tickets sold. Okay. That is the setup that we're going to do here. All right. So let me slide this on over. There we go. So for r of x here, let's start with the current situation, right? The current reality. And the current reality is that we've got, $16 per ticket. So that's the money part. And 4,000 tickets will be sold. Now, notice I'm leaving myself spaces here because while this is the current reality, we want to talk about what's happening when we start changing things. Now it says for each, okay? Now this means for each $1 increase in price, I could do this $1 increase once. I could do this $1 increase twice, 5 times, right? I don't know how many times I'm going to increase the price, but I'm going to increase that price $1 each time. So if X is, 2 changes in the price, then I would add 2. If X was 5 changes in price, I would take 1 times 5, I would add 5. Okay. Now for each time I change the price, the number of tickets sold also changes. And so let me go check out what that said. Okay, so that says we're going to decrease by 100. So every time I change the price by $1, all right, the number of people, the number of tickets, give me a second to move this over. I know how big they're, right? The number of people is going to decrease by 100x. So if I change the price twice, I'm going to change the number of people twice. If I change the price 5 times, I'm going to change the number of people 5 times. Okay, so this is the equation we're going to work off of. And what I want to do now is I want to get this into standard form. So I'm going to do some multiplication, right? Some distributive property here. So r of x is equal to, all right, let's see what we got here. 16 times 4,000. This is definitely going to be some calculator work here. So let me go grab a calculator. And whatever calculator works for you is fine. Oops. Let's see if I can get that over there. All right, so 16 times 4,000, that's 64,000. Let's get rid of you for a minute. There we go. And then I got to do 16 times negative 100x. So negative 1,600x or 1,600. And then I'm going to do, let me slide this down just a touch. Let's see, 1x times 4,000, so that's going to be plus 4,000x, and then 1x times negative 100x, so minus 100x squared. All right, a little bit of rearranging here. We're going to do r of x is equal to, so in standard form, I want my x squared term first, so 100x, negative 100x squared. And then I've got 1,600, so that's negative 1,600x plus 4,000x. It's going to be positive 2,400x. And then the very last thing would be the 64,000 at the end. So this is the equation that represents our revenue, okay, based off of how many times we change the ticket price and then how that will affect the number of tickets. So I'm going to work with this equation down here because this has our information on A, B, and our C if we need it. And then I'm also going to be working up here if I need to specify are the amount of money here and or the amount of tickets here. All right, so all this work, now let me go actually take a look at the questions I'm asking you, right? All right, so the first part is what should be the price per ticket for the revenue to be a maximum? All right, so here's the thing. If I start glancing at question A, question B, and question C, I'm asking you guys for maximum, maximum, and maximum. So that means I want the vertex of this mess. So, all right, back to my equation here. When we talk about vertex, right, the x value of the vertex, we're going to do x is equal to the opposite of b over 2a. So based off of our equation here, we've got negative 2400. I was about to say 24,000. I'm like, one too many zeros. Negative 2400 times 2 times negative 100. So it's going to be negative 2400 over negative 200. Let me go grab the calculator real quickly. So negative 2400 divided by negative 200. That is 12. Make the calculator go away. There we go. All right. So what this tells me, if I look back at my original equation here, remember x was the number of changes. So I need to change my ticket cost 12 times. I need to change the number of tickets sold 12 times. Okay, so x is 12 here. And it says, what should be the price per ticket? So price per ticket, here is the money portion, right? And we're going to do 16 plus 1 times x with the understanding that x is 12. Okay, so back over here. So 16 plus 1 times x. I'll leave it this way for right now. So that's going to be 16 plus 1 times 12. So 16 plus 12. So in order for the ticket price to be a maximum revenue, we're going to be looking at a ticket cost of, and I'm going to do a quick slide over because I want to make this like really huge. Whoops, undo that. All right, slide, 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 slide. There we go. Okay. So that ticket cost should be a maximum, or the price for the tickets to be a maximum would be $28. All right, so there's part A, okay? And then part B is how many tickets will be sold to maximize the revenue. So this is the ticket portion. So that's that 4,000 minus 100x. So whoops, I can barely read that. So I'm sure that means that you guys can barely read that. Let's try that again. There we go. So 4,000 minus 100x. So it's going to be 4,000 minus 100 times, whoops, I was about to write 28 there. That's a 12 for x. So let's go ahead and throw that in a calculator. So 4,000 minus 100 times 12. That is 2,800 tickets. So a lot less tickets sold, but we definitely increased the price per ticket. So what did I say? 2,800 tickets. Okay. And then last but not least, what is the actual maximum revenue? Well, you know that the price per ticket to be a maximum is $28. And the number of tickets to be sold to maximize should be 2,800. So simply, I say simply, but you can just take the cost per ticket times the number of tickets sold, and that would be your maximum revenue. Basically, you are either, right, replacing x in here, and that creates the 28 times 2,800. Or technically, you could go to this equation in orange where everything's multiplied out and replace x with 12 to get your maximum revenue. I'm just going to go ahead and take 28 times 2,800. That is a revenue of, whoops, right with a pen. Right with a pen, $78,400 is the maximum revenue. All right, so we're going to go ahead and close. I'm going to go ahead and close the video here. So this is just question number 1. All right, all the little bits, parts, and pieces to start by reading the word problem, creating this equation, multiplying it out so we can get to some maximum information. And then once we know what X is to maximize, we use that to actually talk about what the ticket price is, how many tickets to sell, and then what the maximum revenue would be. All right, so apparently my little box around my answer there in part C decided to disappear. All right, so I'm going to go ahead and close out the video here. As always, let me know if you have any questions or concerns. I'll see you in the next one. Oops, I don't want a calculator. I want to close the video.